Hi everybody, this is part 2 of our lesson on atomic structure, and in this part of the lesson what we're going to do is we're going to focus on two representations called nuclear format and standard format that let us communicate how many protons, neutrons, and electrons are in atoms, ions, and isotopes. Before we get started with this, I want to remind you from the last lesson that the mass of protons are equal to the mass of neutrons. They're each called one atomic mass unit. And most of the mass of the atom is found inside the nucleus because that's where the two massive subatomic particles are found, which are the protons and the neutrons. Okay, so mass comes from protons and neutrons, not electrons, because electrons are tiny. So this is nuclear format. And in nuclear format, what you see is the element symbol, like uranium, and then the mass, which is 235 mass units right here. So at home, what I'd like you to do is to draw an arrow to this and put symbol, and draw an arrow to this and put mass equals protons plus neutrons. You're going to see how we do this calculation. It's real simple in just a minute. Okay, first of all, since this is uranium, I want to show you where this is at on the periodic table. Down below the bulk of the periodic table, you'll find uranium right down here. And again, that number 92 right there tells you that uranium has 92 protons. I'm going to put 92 protons. Now, because the mass of an atom, ion, or isotope comes from the protons and the neutrons, the other mass units must come from the neutrons. So all we need to do is to put 235 minus 92. And 235 minus 92, I just took out my calculator, it's 143 neutrons. So take a look. If you add the protons and the neutrons, it equals the mass of this uranium isotope. All right, here's P32. P is the symbol for phosphorus. Phosphorus is always going to have 15 protons. Okay, so 15 protons. And then it's got 32 mass units, 15 of which come from the protons. So 32 minus 15 leaves you with 17 neutrons, which would also be inside that phosphorus nucleus. Okay, so again, this is called nuclear format, and I'd like you to write in here that you see the symbol and the mass comes from the protons plus the neutrons. Okay, so for standard format, what I'm going to do is I'm actually going to show you standard format down here in this table. And again, I'm going to ask you to label a couple of things here. The best one for us to go to is this one right down here, which is calcium, and you can see it's got 41 right up here, and it says +2 right over here, or 2 plus. Okay, first of all, in standard format, what you're going to see is the element's symbol, so label Ca as the symbol. In the upper left-hand corner, you get the mass. The mass is 41. In the upper right-hand corner, you get the charge. In this case, it's of an ion. Now remember, on the previous lesson, we learned up here that the way that ions are formed is by a gain or loss of electrons, never protons. And we talked about how if something has a positive charge, that actually means that it lost a negatively charged electron. And conversely, if it has a negative charge, that means that it gained a negatively charged electron. So you have to train yourself to think backwards about those electrons and the charge. So what we're going to find here is that because this calcium ion has a +2 charge, that it must have lost 2 electrons. Okay, so again, what I want you to do is to label this as mass and put mass equals protons plus neutrons. Label this as symbol and label this as charge. Okay, we'll start off with this calcium one since it's what we've been talking about. So, since this is calcium, calcium is right here, and you can see that calcium will always have 20 protons. I'm going to put 20 right here. Now I want you to notice over here that the atomic number is always 20. Because up here, I want you to label atomic number, and I want you to put it equals number of protons. So what you're going to find is that the atomic number is the number of protons. Those two numbers are always the same. Okay, now we can take a look at this 41. You labeled this as mass. So I'm going to put this right over here. It's got 41 mass units, or the mass of this ion, or this isotope of calcium ion, is 41 atomic mass units. Now remember that the mass comes from the protons and the neutrons, so we can say 41 minus 20 protons leaves you with 21 neutrons. Now remember, since this has a positive charge, and we learned on the previous sheet that the way that ions are formed is by a gain or loss of negatively charged electrons, never protons, since it's got a positive charge, it must have given away 2 negatively charged electrons. For that reason, it must have 18 electrons. Notice that it's got more positives than negatives, which is why the charge on this ion is positive, and +2 in particular. Okay, let's skip up here to phosphorus. Now you can see this phosphorus isotope is a little bit different than the phosphorus isotope that we took a look at right up here, because this is called P32, whereas this is called P31. It's got a mass of 31 atomic mass units. Now it tells us right here that phosphorus is going to have 15 protons. And remember, we saw from the calcium example that the proton number is always going to equal the atomic number. So the atomic number of phosphorus is 15. We can also see that this has a mass of 31 mass units. So its mass number is 31. And we know that the mass comes from the protons and the neutrons. So the sum of these two numbers always has to add back up to the mass number. So we can say 31 minus 15 leaves us with 16 neutrons. Again, see how this adds back up to that. Okay, this is neutral. There's no charge in the upper right-hand corner. And so this is going to have an equal number of protons and electrons, and so it's going to have 15 electrons. Okay, this one right down here, fluoride ion. It's got a charge right here of -1. Now let's take a look at the periodic table and find fluorine first. Here's fluorine. Fluorine's atomic number is 9, and this means that it has 9 protons. So, 9 protons, atomic number of 9. See how the atomic number is always the number of protons. Now, we're also given in the table over here the mass number, which is 19. So remember, we can say mass minus protons equals neutrons. So 19 minus 9 is equal to 10. Now, as far as electrons go, see how it's got a negative charge. This must have gained a negatively charged electron. If it was neutral, it would have had 9 positives and 9 negatives, but it's got a negative charge, so it must have 10 negatively charged electrons. Okay, here's iron. Let's find iron real quick on the periodic table. Iron is element 26. This means that its atomic number is 26, and it also means that it's got 26 protons. Oop, that's electrons. Whoops. Okay, since it's neutral, the protons are going to equal the electrons, and so it's going to have 26 electrons. All right, the atomic number is also 26. And for mass number, remember you define mass number as protons plus neutrons. So the sum of these two numbers, which is going to be 55, is going to be the mass number right over here. Okay, we've already done the row for calcium ion, and now we move on to arsenic. Now, the information that's given about arsenic from the table is this particular arsenic isotope has 42 neutrons, and it's got a mass of 75. Let's take a look at the periodic table and get a better understanding about arsenic. Arsenic is element As, and it's element number 33. That means that it's got 33 protons, and its atomic number is 33. So arsenic, 33 protons, atomic number of 33. We also know, because it's given right here, 75, its mass number is 75. Okay, as far as electrons go, electrons are going to be equal to protons because it doesn't have a charge. So 33 protons and 33 electrons. Okay, so that's how you can take information that's given in standard format and complete a table like this. Okay, just to review real quickly, remember, we're going to learn about two main ways that we can represent protons, neutrons, and electrons in atoms, ions, and isotopes. And those two ways are nuclear format and standard format. For nuclear format, you get the element symbol, which is going to tell you the atomic number and the number of protons, and then you get the mass. And so all you've got to do is to take the mass number minus the protons to find the neutrons. For standard format, you get symbol, mass number, atomic number, if it's given, is going to go in this lower left-hand corner, and then the charge goes in the upper right-hand corner if it's a charged ion. All right, thanks a lot, guys. Have a good day.